Hello, everyone. Thank you for joining us today as we come together to learn more about breaking the monolith on application modernization. My name is Hassan Mohsini. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors, as you know, are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft partners and the open source community. It's also home to the Microsoft for Startups program. With a diverse mix of hands-on workshops, expert panels, and community events, there's something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our speaker today, all right, yes. All right, so our speaker today is Niel Zeeman. Niel is a Microsoft MVP and a DevOps Solution Architect interested in all things processes, quality, and technology related. He consults on DevOps, ALM, and dev processes and methodologies, speaks Azure DevOps, and in his free time, he tinkers with IoT while consuming pre-built AI models. Feel free to ask questions during this session. We will have regular stops, and also we will connect with you on Twitter. The hashtag is Reactor Abu Dhabi and MSFT Reactor is the Twitter handle. So please send us some tweets, connect with us on Twitter and socials, and also keep an eye on the Q&A tab. This is where you can send questions, and I'll be sharing some links and resources relating to today's session. The session is recorded and it will be available later on our YouTube channel. I'll put the link in the Q&A for you as well. And with all that said, I would like to hand over the mic to our speaker to start today's session.
Why, thank you. Let me just share. Okay. Can you see that?
Yeah, it's all good. Your slides are up.
Cool. Thank you very much, Hussam, for that introduction. Yes, so today I'm going to talk a bit about application modernization. So the theme is about breaking up a monolith and how we go about it, some of the concepts and architectures and why you would consider it adopting a cloud strategy to modernize applications. The talk actually originates where one of my clients asked me about AWS and how well I knew it. And I know this is a Microsoft event, but nonetheless, some will have to forgive me. I'm going to be talking a bit about AWS and the comparison services between Azure, because I know Azure and I wanted to sort of delve in and expand what I know with regards to AWS. And I sort of went on this journey to go and learn and study, and I looked at a whole bunch of overviews and stuff from AWS's side and the TLAs, the three-letter acronyms, which will drive you crazy. Anyway, so I eventually got to a stage where I decided to take a sample application and sort of break it apart and how I would then map those sections out into the various services that are commonly used in Azure, and of course how that relates to something that would be available in AWS. So this was an interesting sort of a journey for me, and I thought this might make a nice talk. So yes, let's delve into it a bit. And as Sam said, my name is Niel. My contact details are there on my Twitter handle. Feel free to reach out, and yes, if you have any questions, I'm sure some will happily answer them while I'm busy waffling on. Okay, so to start off with, I've got this sort of a classic commerce site, if you want to call it that. It's a web application. It's got a bunch of pages. It has a product catalog, and you can perform simple searches, some user profile management. So you need to log in and see what your history was with regards to orders that you've placed. Some of the stuff like your details, your addresses, that kind of stuff would also be kept there. We've got a cart where you would put the items from your product catalog into the cart. follow a payment process, connects to a third-party payment gateway. Then orders are submitted and concluded through emails being sent out, passed to a warehouse, and the warehouse will be responsible for fulfillment. And of course, as with most sort of oldish applications, all the information is stored in a good old relational database, and it's hosted on an IIS server behind a firewall, most probably running on a VM somewhere. Now, looking at this application, it is a single big application or a monolith, and we could make the argument that it is actually a legacy application. Now, why do I say that? Well, for one, it works. And if you look back at the last number of years, there haven't been any big changes that has happened or occurred in this application. So it's fairly static in the technologies and what it's doing and how it's operating. And that's, I'll get to that bit more on the reasons why a bit later. But it's also probably just built on a good old fashioned 2 or 3 tier architecture. So we can make the argument that it's a legacy because of those. And with the concept of being a legacy, we also sort of get the problems and possibilities, such as it's difficult to change. JetBrains, JB Rainsberger, said that the definition of a legacy application is it's profitable code that we feel afraid to change. And there's a lot of reasons for that. Technical debt accumulates over time. The skills and the knowledge of the people who have worked on this application gets diluted. People move off onto different applications, different teams, different companies. And you sort of end up with something that looks like this. So with this, as the time increases, the effort and the cost to make changes, to add new features, to fix bugs, sort of starts outweighing the benefits of actually doing it. And things start to slow down with regards to how quickly you can adopt into new technologies, new processes, new frontiers, and unless, of course, you're willing to spend the money to do that. Errors are starting to pop up, and they're difficult to track down, because we all know that you make a fix in one area of the application and inevitably something somewhere else also breaks down. There are few automated tests, if any, and we all know as time goes on, and especially your older, more difficult to test applications, when the tests start failing, the easiest way to fix a test is to comment it out. It's starting to slow down, and this could be because the database was not designed to cater for the vast amounts of historical data that has accumulated over years, and it's expensive to scale up, which would inevitably incur downtime. And to scale out would also be difficult because it would be expensive to provision new hardware, to set up new environments, to boot new VMs, all that kind of things. Third-party integration, they tend to change a lot quicker than the application does, or they just simply get more expensive as time goes on, and it becomes more cumbersome to adopt the changes, to make the fixes, or to just change to a different provider. Because of the monolithic approach in this application, it has a single attack surface. So once you get onto the server, that's pretty much it type of approach. And then it's just not cool. And as funny as that may be, it is very difficult to attract new people, new developers with old technology. So those are some of the problems that you could face in the legacy monolithic type application. And in this journey of modernization, so what would a new or a modern application actually look like? And there's a lot of buzzwords that's flying around there. And I think, in my opinion, that some of the foundations of a modern application is that they should contain some of these concepts or these sort of aspects. First, of course, microservices. You can't be a modern application without microservices, right? But the basics is that these are small domains that are manageable. You make a change in one small service, deploy it with relative ease and with little impact to the rest of the system. And when I tell you, I've seen instances, if you have to deploy the entire application to make a fix in one area, you are not adhering to microservices principles. Containerization. This is a very nice way of enforcing this microservices boundary, basically. Provides mechanism to transport the service or application or process in a non-mutable fashion. And this makes it easy to run tests as a unit because they are small and concise, and it also reduces the surface from a security point of view. It reduces your attack surface. Of course, we can't talk about modern applications without the cloud. The fact that owning your own data centers is expensive, it is outdated, and it's inevitably prone to capacity problems. It just does not provide you the ability or the agility to test hypotheses, to have access to resources when and how you need it, the ability to scale on demand, okay, and even consume services that you thought last week you'll never need, okay. This is all what cloud offers for you. And I'm talking about sort of infrastructure point of view, but why would I want to care about that? I want to abstract things away from the hardware or the infrastructure point of view, and this idea of serverless fits in very nicely with something like your microservices concept. Little pieces of functionality that builds a whole. They're available individually, but they can also scale at a drop of a coin. Leveraging machine learning and AI, we need this. We want to make informed decisions at unimaginable scale and speed. Everything is about data. You know that old adage where if you don't know what the product is, then it's probably you. It's all good and well to have all of this data, but if you're not doing anything with it, then it's pointless. So we can use this data, we can train models, we can quickly and efficiently look at vast amount of data. We find stuff from potential fraudulent transactions, fake news, user buying patterns, diseased crops on farms, simply respond to the majority of repetitive customer queries so you can focus on issues or areas that really matter. We should be taking all of this and actually making the bulk of this mundane stuff someone else's problem. We should focus on the things that make us stand out. Why would a call center care about wiring up a PABX? Or financial institution, why would they worry about how to install a Kubernetes cluster or OpenShift on a server in their data center? Then all of this feeds to the ability for us to focus on what differentiates us from our competitors, being able to make changes quickly and efficiently. We should be automating as much as possible so we can get that critical bug into production in a matter of hours and not weeks, so that we can get that new feature that will make us stand out even further out in the market in a fraction of the time that it would have normally. And you know, looking at all of these sort of concepts, if you aren't doing it, then your competitor probably is. Okay, so I've covered a few concepts, a few problems that we would face, and sort of get an understanding of what a modern application might entail and look at. So on that note, I'm going to go back to our monolith, and we're going to start talking and probably get a bit opinionated about how we're going to start approaching this. So I'm basically going to take this up and start talking about the technologies and the services that I've come across, and where they might be applicable in the system as a whole, and where it would make sense to incorporate them. The first step that I'm going to take is I'm going to look at the application itself, and I'm going to draw out the contextual boundaries. Now, Eric Evans spoke in his book about domain-driven design. He spoke about how to draw out your domain, but more importantly, he spoke about bounded context, and I think that feeds very nicely into this concept or idea of a microservices mindset. And looking at how we've sort of drawn out these services of our application, we could probably just containerize this and shove it into a Kubernetes cluster and call it a day, right? But I'm more interested in reducing the amount of work and leveraging what I can from elsewhere so that I can focus on what is actually important. First of all, I'm going to see if there's any questions I should be aware of. Okay, so there's one question about running your application on a single cloud provider or choosing multi-tenant mode. Well, I mean, what I'm talking about, what I'm covering here is merely services. It doesn't matter which provider it is or where it's running. If you have access to that service, then you should be able to break up your application very, very competitively. Okay, so getting back to our domain and our context over here, the first thing on top of our list there is authentication. Now, this is a pain at the best of time. I mean, you talk about username, password management, encryption, MFA, all that kind of stuff. It's a hassle at the best of times. And I know I get annoyed when I have to go and create new login credentials for every site that I visit. So everyone uses sort of your social credentials these days, and this is the route that I'm going to try and follow here. And looking at the services that is available, it is surprisingly easy to do that. If you look at Azure, Azure has a service called B2C. AWS has Cognito, AWS Cognito services, but this gives you the infrastructure to integrate with and take all that hassle away from you. So if you think about password management, you think about MFA or multi-factor authentication, all that kind of stuff is handled by something else. What you get in response is an authenticated person or an entity. You can still store some of the information in the application where it makes sense to do that, but the hard work, the safety and security is done elsewhere. Great, so that's off to a good start. Next up, the glossies and static pages. Okay, so this is like the overview, information, contact pages, and all that kind of stuff. Currently being stored as part of the web application. I want to separate them out because I can, and a cheap and easy way of hosting your sort of static applications, single page applications, would be the blob storage, or in AWS's case, your S3 storage. It's quick, it's easy to set up, and it's cheap. Now, I could have gone web app or Elastic Beanstalk instance. Yes, I could have, but I thought this was just a better way of looking at the different usage potentials and usage scenarios. Besides, I'm going to be looking at those now, actually. So once we've got that out of the way, we're looking at our catalog. And This is basically a mechanism to show us a list of items that is for sale. It's got some basic search capability. If you think like select star from description, we can add then an item from this catalog into our cart and take that further. And at this stage, I'm going to sort of complicate things a bit, but I think the user experience will be a lot better for it. So I'm going to break this out. And first of all, I'm going to host the application in a AWS Elastic Beanstalk or app service. Now, both of these options, fortunately for us, they have a container option. So we could package this in a container and then deploy it into the service. Okay, great. So that's something to take note of. Secondly, we need to store the information for this catalog. And for that, I want a read optimized environment. And we'll leverage our good old-fashioned relational databases for this. So AWS RDS or Azure SQL will fit in very nicely for this. Now, the thing to note here is that it is good to store your data in a database, but if you start looking at your binary files, your large files, PDFs, images, that kind of stuff, you do not want to store that in a database service. It's way too expensive to store that in there. And for that, I'll just simply use our good old-fashioned blob storage or S3 instances and reference them from there. Next up, we actually want to take that a step further and optimize the database access even further. I don't want to hit those databases. It's an expensive resource, and I don't want to hit them millions of times unnecessarily. So for that, I would go and take a caching approach, and we can cache the catalog, search results, certain images, certain files, that kind of stuff, using something like your Azure Redis cache or your AWS Elastic Cache. Speaking of search, now currently, like I said, very simple search, very basic. And here in sunny South Africa, we've got two larger online retailers, and I don't want to name names, but you can clearly see that the one has invested a lot more time and effort in just the simple search capability on the site. I was looking for a product a few weeks ago, and I just went to both of these. And on the one, I found it almost instantaneously. On the second one, it took me probably about 15-20 minutes to find that exact same product to do a comparison. Now, that would turn people away. So you need to look at making these kind of services as easy and as intuitive as possible. So we want a better search experience. We want better performance in our search. We want predictive searching. We want our searches to be multilingual. Now, once again, fortunately for us, we have AWS Elasticsearch or Cloud Search. Elasticsearch is, of course, just based off of Elasticsearch, which is open source. It's a bit of a pain to set up in AWS. Azure makes it easier for us because we have the cognitive search in Azure that provides all of this capability for us out of the box. Now, because we need to understand that a stable application is one that operates in the absence of errors, and by the time that your service becomes unstable or issues start becoming apparent, things have already started going wrong. Okay, things have started failing. We want to proactively monitor what is happening in this application. If you think of things such as how is the service being used, what are the bottlenecks, and how is the consumption growing in the service. Now, once again, fortunately for us, there are services we can use. AWS has CloudWatch, and Azure has had for a while your Azure Application Insights that feeds into a lot of sort of analytics type of services in Azure. And this will give you everything from notifications when you start hitting resource limits or usage limits, or when errors occur. You know, these things can be very detailed with, once again, very minimal effort on your side to incorporate this in your application. So, catalog, done. Cart, checkout, some of the aspects around that. We sort of take the same approach as we would with a catalog, but I'm going to mix it up a bit, and I'm going to use sort of the approach of using a NoSQL database just to be different, and because my script says so. So AWS has DocumentDB or DynamoDB. Azure, we've got table storage, which is kind of the poor man's DocumentDB. We've got Cosmos DB. The use and decide which one you want to use, you would have to go and spike a business process or a business case for yourself to see which one would fit and which one would make sense for you. Here, I've just got DynamoDB and Cosmos because, quite frankly, they've been around and they've got very good support for different languages. Then, on completion of our checkout process, we want to sort of take that information and send an instruction to the warehouse to process from there on. And I want this to be decoupled because I don't want the checkout or the cart to sit and wait for the actual delivery of these items, and can basically sort of see this as a send an instruction and forget about it type of approach. Now, to do that or to enable that, I'm going to put this instruction on a queue, and AWS has SQS or SNS. See, I wasn't playing with those TLAs with AWS, so it's simple queue service and simple notification service on AWS. Azure has the service bus, event grid, queue storage, and the different systems provide different capabilities. So if you think of pub sub, you think of routing, you think guaranteed delivery, all those kind of stuff. And that's not even talking about your other services such as RabbitMQ or Kafka. On our journey, I want to keep it simple, and a very basic queued item will do more, will suffice for our requirements. So yeah, and for that I'll just stick to the AWS simple queue service or Azure queue storage to handle that process. Now, part of this checkout process, we also want to integrate with a third-party system for the payment gateway, and there's a number of ways to do it, but realizing that it can be very brittle. Those payment gateways update very often, and you need to segregate them out of your basic pipelines or your basic architectures. And a nice way to abstract that away from your functionality is use a small function, something that can scale easily, you know, for when we start processing millions and millions of payments. It's already Christmas, so around about now. So AWS, we've got Lambda functions. Azure, we've got functions, and this will sort of fit in very nicely. It's so small, specific routines that can get updated asynchronously with relative ease. Sort of think of a single responsibility principle. After the checkout is completed, we need to instruct the warehouse, and then we need a system to pick up that instruction and process it and let the warehouse pick the item from the warehouse, ship it using courier service and all that. Now, as I was mentioning in the cart subsystem, the entry point here would be the instruction that gets put on the queue. And then we want to kick off sort of a basic classic workflow. Okay, we need to send the request to the warehouse to inform them what items they need to get. We need to get feedback from them to say when they've shipped it, which courier they shipped it. Then we need to inform the client that with the courier details, when it's supposed to get delivered, and finally also want some feedback to say that it was delivered and that it was successfully delivered. So all of this sort of processing, I'm going to sort of bunch together in a single sort of sequential workflow. And lucky for us, there are workflow systems in both providers. You can look at something like your AWS SWF or Simple Workflow Service. And then, of course, in Azure, we've got Logic Apps. Both of these services have very good third-party connectivity. So you can connect to various apps and services. And if there aren't any connectors out of the box, you can go and write yourself a little serverless function to perform that connection. So speaking of which, we need to connect to our warehouse system, and we will then be able to create a function that serves as sort of a anti-corruption layer between our workflow and the warehouse, but giving us the ability to bring the warehouse as part of our workflow. Then the next step is we also want to send out these communications. We want to get the word to the clients in whatever channel or communication preference they have. And AWS has a service, a simple notification service that can handle emails and SMSs and all that kind of stuff. Azure, nothing built in publicly available yet. But they've got a SendGrid service that performs a lot of this, and we can just spin one of those up and consume it. And this service is actually usable through the entire application. So we can actually then use this as a basis of a communication throughout the system. Okay, so next up is our historic information. I know that's vast amount of data that slows down everything because we never built the database to cater for all of this. We've consumed this data, we've trained our models, but we now want to take it and stash it somewhere cheaply and safely and available for future potential use. Now there's a couple of options available. It's basically just different tiers of storage in both providers. So we've got the AWS S3IA or infrequent access class and a Glacier class. In Azure, we've got cool or archive tiers in our blob storage. It's a lot cheaper to dump the data there than to keep this in our database systems, because like I said earlier, having your database services, they're not cheap services. And at this stage, our central database is old news, so it's pretty much been absorbed through our various systems and the bits of information that they are in control of, so we can hide that a bit, make that less prominent. Okay, so now I want to take sort of a step back and look at it from a bit higher level view, a bit broader, and how we can take this expanded topology and make it or represent it as a single cohesive system. First, I'm going to take the services and put them behind a gateway of some sort. So in AWS, we've got the API gateway, and in Azure, we've got API management. And this is fairly key in that it provides a whole bunch of capability, but at the top of the list there is your routing and versioning. So we've got multiple we can have multiple versions of the API running concurrently at the same time. And this gives us the ability to deploy when we want to, and then simply route the traffic from the new version from the old version to the new version. And if something horribly goes wrong, we can then take this and roll it back to the old version. So this gives us ability or the agility to deploy frequently and in small increments. We can obviously get rid of IIS because most of these services are web accessible by nature. Then I also want to go and I want to slap on an access point. So in AWS, we've got the global accelerator. In Azure, we've got front door. Once again, this does a lot or provides and gives us a lot in terms of security, giving you regional point of access or point of presence, traffic routing, and it also actually provides some caching. But I'm still going to put on a CDN or a content delivery network node here, and you'll notice that this is not branded. And the reason for that is because you can get into quite philosophical debates around the services, and most people will tell you something like Cloudflare is a better option as opposed to your AWS CloudFront or your Azure CDN. Personally, I don't like Cloudflare because it takes over your DNS, which I actually prefer Azure CDN. So I'm not going to brand that, but I'm going to put it in, just to make the diagram look a bit more cluttered. Speaking of the clutter and all my well-crafted, complex-looking animations, I wanted to sort of summarize the topology a bit. Each of our mini services will leverage what it needs from this host of services that I've mentioned to perform its job, okay? And it should not be as complicated as a lot of my previous slides might make it look or portray it to be. As long as those the interfaces between these systems are well defined, this gives you the ability to swap out services at each point or at any point for something that is potentially a better fit for your business, be it from a functional point, from a feature point, or even from a cost point of view. And as per that previous one, it could be an Azure service and you'd be swapping over to a Google-based service or a AWS service. It should not matter. These are the benefits of having cloud native applications. Okay, so this is now sort of going onto your cloud providers, but I can't not talk about DevOps and automation. Let's see if there's no more questions. Cool, so carry on. So this is my forte. We want to manage the developer environment or the developer processes all the way from the development sort of environment to the production environment. We want to make those deployments as easily and quick, as painless as possible. We want to get those fancy new features, the critical bug fixes to production as soon as possible. Now, both AWS and Microsoft have their developer platforms. AWS has what they brand as code services, and it contains code commit, code build, code pipelines, code deploy, I think. And their tagline is host code, build, test, and deploy your application to AWS. Azure, not really built in Azure, but you've got Azure DevOps with boards, repos, pipelines, and there's a tagline, build, test, deploy with CI/CD that works with any language, any platform, and any cloud. Now, I'm biased on the Microsoft Azure DevOps environment, so I'll leave those taglines to resonate with you a bit. And then of course there's also GitHub, the new kid on the block. Now, the bring those back. Okay. The difference in how these platforms would talk to the providers is basically through CLIs, and one of the methods is the CLI, and it's how we can take these instructions and execute them to resources within the platforms. So if you think about your infrastructure as code type of mindset. Now, as I said, CLI is basically a bunch of commands or statements that you would execute that would take your instruction and then create these resources in your application. And both environments have a very good feature-rich set of CLI. The next step is your templating type of approach. So in AWS, they've got CloudFormation, and in Azure, we've got ARM templates. And this is basically a way to describe your entire resource structure as a text or JSON YAML type of document. Then we can tell the provider to apply this. And what will then happen is the provider will spin up, configure, or reconfigure the sources based on this definition. The next thing is where it gets a bit more interesting, because AWS has the Cloud Development Kit, and this is basically a codified version, a domain-specific language, and you can access this and develop these resources or describe them in code if it's C#, Node, JavaScript, and Java. You develop using the DSL, you compile it, execute it, and then the templates that come from that you can take and apply to AWS. There is nothing like that at this point in time natively for Azure. There are third-party tools. Pulumi is one that actually targets AWS, Google, and Azure. There is an open source one called Farmer that works quite well. And Microsoft is also working on a brand new language, Bicep, which is also DSL, to be able to do this. Okay, so we've gone through, we've discussed some of the problems you could face with a legacy application or monolithic applications. We looked at some of the descriptors of a modern application, and we looked at how we could step through this application process and dissect them into small services, and how we can actually take a lot of that infrastructure requirements or development effort from our shoulders and put it onto another third-party system or service that we can just leverage to enable us to focus on what we need to focus on. I was very selective in the services that I used. There's a large number of different services and even more popping up on a monthly basis. I know now the Azure, instead of using the blob storage for your static pages, they actually have a static web app service specifically catered for static pages, for single page applications. Now they're actually adding Blazor support. And from a communication point of view, I said there's nothing as such in Azure. Well, there is now. Azure Communication Services is in preview. It handles your SMSs, all your channels like Teams and that kind of stuff. Just does not allow email sending yet, so you still need something else for that. But I hope the intent came across that I was trying to give you sort of coverage of the basics here, and that you can sort of see some of the possibilities in reducing your workload, your infrastructure, and your codependencies. Thank you, and if that was interesting, let me know. And I'm always looking for new topics or new things to learn myself and delve into from a development or technology point of view. So if there's any feedback, feel free to let us know, and thank you very much for your time.
Thank you, Niel. Right, I see one more question coming in. I also saw that you mentioned Pilomi, and we had a session about that earlier. So I linked that for
Okay.
the community members also, the past session recording on our YouTube channel, so they can check it as well.
Cool. How do you do data migration from legacy to new applications, since how we don't have a single database? That is a very interesting, long, in-depth discussion, because you need to look at what the services are that you'd be looking at, what services come from, what does the data look like. So you would handle this, once again, piecemeal, take the little bits of data that you need over legacy stuff, put that in a long-term storage, cheap storage kind of place, and then leverage them as and when you need it. Okay. I don't see any other. Can we run on a single? Oh, I got that one. So I don't see any other questions. If there's any questions, please let us know.
All right. Meanwhile, I'll mention two modules and learning paths that you recommended. I'm gonna start sharing my screen, and for the community members, they can still send us questions. If anything comes in the next couple of minutes, I'll share them with Niel. Let me just
stop my sharing.
Yeah. All right. I started presenting. All right. Yeah. So these are a couple of learning modules that I'm gonna share the links to in the Q&A. Check them out. So the first one will be on Azure fundamentals. Niel recommends this if you want to continue the journey after this session and take this one. It includes 12 modules. It covers everything from the very basics, fundamentals using Azure, and then also there is this one on architecting modern applications in Azure. So you can also check that.
The modern applications in Azure goes quite a bit into your containerization, and a lot of what I've discussed now, it doesn't disallow containerization. I didn't explicitly allude to it being containerized, but it can. And like I said, your app services and stuff has containerization built into it, so you can leverage on numerous areas, on numerous services.
Beautiful. All right, I got these two links for everyone to check out in the Q&A, and I don't see more questions. So I would like to encourage you, don't forget to send us some feedback about the session. There's a code that you will need to enter on the survey. Basically, it's 11812 for today's session, and basically would love you to tell us more about the topics that you'd love to see at the Reactor, interesting sessions and topics that you're keen to see. And Niel and I had a conversation earlier. He's also thinking of doing another one later on in the Reactor. So some feedback around the topics that you'd love to see will be highly appreciated. And also don't forget to subscribe to our YouTube channel. This is where you'll find today's session and a couple of days on that channel, and check out the calendar on Meetup. We have plenty of upcoming sessions this week and for the rest of the month. Connect with us on Reactor, Twitter. MSFT Reactor is the Twitter handle, and the hashtag is Reactor Abu Dhabi, and sign up for our monthly curated newsletter. This includes all our upcoming events and sessions and workshops that we're doing. And with all of that, thank you again, Anil, for joining us today, and thanks for everyone who joined the session. Stay safe and goodbye.
Thank you.